So in this second lecture, what I wanted to talk about is basic hypothesis tests. Now, these things aren't necessarily difficult, but they can look a little bit weird when you first see them. Now, I also think it's important to realise why we're actually doing these things, and I would say really basic hypothesis test is where, as far as finance is concerned, proper quantitative methods really start. Okay, so there is really a genuine reason for studying these. If you don't study these, all you can do is basic graphs and frequency tables like we did in the last lecture, and what's really the point of that? Okay, so it can look a little bit weird at first, but it isn't necessarily hard per se. And I do think this is fundamentally interesting because it means you can do harder and more interesting things like regression and other methods in finance, which are ultimately more interesting and closer to my day job as a finance researcher. Okay, so these hypothesis tests, I think they are of foundational importance, and they are interesting, not really in and of themselves, but what they ultimately enable you to do in terms of regression and the sorts of harder methods that we'll begin to look at towards the end of this course. In terms of background reading then, so I recommend this book here by Gujarati and Porter on basic econometrics. It's regarded as a classic teaching text. Now you've got a lot of resources on the module, so you've got these recorded lectures, the module study book in PDF format available from the Canvas page, and you've got PDF copies of these lecture slides as well. So I've tried very hard for this course to make the lecture notes as self-contained as possible. So I've given you a reference to a textbook there by Gujarati and Porter. I'm also going to try ultimately and write these lecture notes into a book myself. So you have got quite a rich source of information in these lecture notes and in the other Canvas materials. I will try and make the lecture notes as self-contained as possible, and what I ought to say as well is that in the past I've had students who've been able to teach themselves just from the lecture slides alone. Now here you've got a module study book, which essentially is a copy in full sentences and full text of the lecture slides. My reason for saying this is whilst I tried very hard to get the lecture slides and the module study book just right, it's possible you might find the lecture slides actually better and more succinctly summarised. So I wanted to say here a quick note on software. So this is quite ambitious to do, but I'll try and deliver the module as best I can using two different software packages, R mainly, but also eViews. But if you sort of told me between the two, then I wouldn't hesitate to recommend R in place of eViews. So R is genuine statistical software. It's freeware, so it's a lot easier for situations like this where you're working off campus. It's also increasingly used in data analytics, and I would regard it as professional standard software. And the other thing to say here as well, because it's freeware, you're guaranteed to retain access once you graduate from the university. Now, it looks a little bit weird when you first see it, but just think R for robot. So you need to use a command line, which does look odd when you first see it, but actually gets easier with practice. So this does come at the cost of you have to think carefully about what exactly you want the computer to do, but it does give you more flexibility. So it is very much like if you're driving a car, the comparison between manual versus automatic. So manual, harder to learn, but gives you more flexibility. So I would say in contrast to our eViews is primarily used for teaching, but I have used it as a finance researcher when I worked in London. R is freeware, so various parts of the logistics, especially this day and age, work better. You don't need a university software license. I'll try and do R and eViews software examples. It's much easier for me to do examples. But I wanted to try and emphasise why the lecture is important. So past MSc dissertation students of mine have used related techniques in their dissertations and done well on their dissertations. So in 2013, one of my students used related techniques to analyse mergers and acquisitions. So the easy sell for me here is to say, even if you're not necessarily interested in these techniques, you might be interested in mergers and acquisitions. In 2013, one of my students used a paired t-test to analyse accounting ratios, and again I think it's an easy sell for me here. If you're not necessarily interested in the techniques in this lecture, you might still be interested in accounting ratios. And then the year after, my students were using things that were slightly more complicated. So my students were using things like time series econometrics and unpaired t-tests, and they were managing to get distinctions on the back of well motivated and well used statistical techniques. Now the main point of this lecture, as well as being important for dissertations, is linked to regression. So regression is the prototype model for all applied statistics and econometrics, and is a really big deal for finance research. So it does underpin much research in finance, economics and social sciences, and despite the title of the lecture, it will ultimately help you understand and apply advanced regression techniques even if it's not got regression. So the basic golden rule, as we've hopefully seen, is don't panic. So maths is usually simpler than it seems at first. So we showed you in the last lecture that a lot of the basic techniques basically boil down to revisiting some of these basic graphs that you have seen before in high school maths. Often the questions you are wanted to ask are quite simple, but despite that simplicity, they're still powerful. And please remember as well, it's not about being Sheldon Cooper off the Big Bang Theory or Spock off Star Trek. Math is usually designed to make sense and to convey useful information. And the conveying useful information bit and the communication bit is going to be absolutely central. Okay, and this is one of the key elements I was trying to get across from the lecture last time, in the first lecture. So it says that maths is usually simpler than it seems at first. So a lot of the regression methods that we will look at in this course will be based on a sort of extension of these basic graphs and basic ideas from high school maths. But what you'll also see, even though this might look a little bit strange when you first see it, is that lots of the regression tests are essentially a different version of the techniques that we will cover in this first lecture on basic hypothesis tests. So if you have a general data set then, so there are these two things that are usually of key interest: location and scale. So in terms of location, although this is a technical, mathematical and statistical word, what this is really saying is, what is a typical observation? Literally, where does a typical observation live? And the question that you might phrase in statistical terms would be asking, what is the mean? Now, in terms of dispersion or spread, the natural question to ask here is, how spread out is the data? And you might phrase this in statistical terms as, what is the variance? Okay, and the point of these techniques in this lecture will be that these two questions about what a typical observation is and how far spread out the data is in a systematic way using hypothesis tests. Now, it looks a little bit strange when you first see it, but these generic data techniques then feed forward naturally to regression. Regression, as I said before, to y is x increases this extension of the basic ideas from high school maths. Does y increase, decrease, or nothing happen? And it turns out that the statistical techniques you use to answer these first two questions are also useful in regression when you've got a slightly different question that's more obvious relevance to finance and accounting. So if you're analysing a general data set, then there's two basic questions. What is the location or the mean? Literally, as I said before, where does a typical observation live? And the second aspect you might want to look at is the spread or the variance. So it can be a little bit confusing when you're calculating things like the variance and the standard deviation, what these things actually mean beyond the nuts and bolts of the calculations. They're trying to measure the spread or dispersion in the sample. Now, answering these questions systematically is vital for research, and that's really the point of statistics, that it's giving you a systematic tool set that you can use, in principle at least, on any data set. Okay. And the systematic bit is going to be really important for real research questions and for real data sets. First question on location or mean, you can answer using the one sample and two sample t-test that we'll talk about in this lecture. Second question on the spread or variance in the sample, you can answer using the chi-square test and the f-test. And then it turns out these tests here, the t-test, the chi-square test and the f-test, have more general application to regression type models when you're trying to look at more interesting things that have a clearer relevance to accounting and finance. This is the general mental picture to have in mind then. So the location, literally, what is your best guess of where a future observation will live? So the reason for the name, as I keep repeating, is location just refers to where does a typical observation live, what's your best guess of where the next observation will be, and then alongside that you want some of margin of error. This combination of your best guess and the margin of error is actually quite a subtle point about statistics. It's not just blind application of mathematical techniques. Divisional square gives you this idea of margin for error, how far away from your best guess are you likely to be in practice. So location is typically measured by the mean, and you would look to sort of test for this using either one sample or two sample t-test or ANOVA and regression techniques. And the question about the dispersion or spread can be answered using the chi-squared test and different versions of the S-test. And as I tried to sort of motivate this before, okay, you start with these sort of basic techniques and they have broader application, I should say, to regression problems that are more clearly linked to interesting accounting and finance topics. So in terms of the outline of the lecture then, so I wanted to go through the one sample t-test and the one sample variance ratio or chi-squared test, two sample t-test, and then a two sample variance ratio or f-test. So this is sort of split up at the sample variance ratio or chi-squared test is a little bit non-standard and so is examinable. The sample t-test and the two sample t-test are answering questions on and then this chi-squared test, f-test, are measuring about dispersion. Retain those two fundamental questions that we want to ask for any data set. What's the location? Look at the sample t-test or the two sample t-test. And what's the spread? Look at the squared test or the f-test. And then what I wanted to do at the end is give you an extra example of the chi-squared test for data on observed counts. So unfortunately there's some repetition of the squared test, although these things are doing things. Now what I wanted to say here as well is that 2 on the list and then 5 on the list, which we look at it, these are chi-square tests. These are not examinable, but I thought it was useful to go through these on this lecture course because they might be of use for dissertation students. So wanted to sort of give you an example in the lectures then about how to apply this one sample t-test. So suppose we've got data on the following slide on customer confidence in 2007 and 2009, and you want to see if the crash of 2008 has a lasting impact upon the consumer confidence. So consumer confidence on, you subtract the consumer confidence for 2009 from the consumer confidence in 2007. This gives you a measure of the difference consumer confidence for each month, and then you want to more statistical test, in this case one sample t-test, to see if there's if this distance variable has a mean that is significantly different from 0. So if the mean of this difference variable is significantly different from 0, then this gives you evidence that there is a tangible, detectable effect on consumer confidence that is caused by this crash. So it's a slightly doubly example. The systematic bit is still projects and for real data sets. Is there a detectable difference between what you would by random chance alone? The detectable difference bit emphasises that you're undertaking a systematic approach, which is again very, very important.